A lot of people ask me why I choose the acids and bases that I do for various jobs, various tasks that I do at home. And there are a lot of reasons behind this based off of the solubility of the final product or how toxic it might be as a final product. For example, reacting hydrochloric acid and sodium hydroxide together, fantastic, it makes table salt, but maybe I don't want table salt. Maybe that's not good for my use of it at the end. And I'll explain some of that in other videos for why I choose what I choose. But either way, let's first talk about acids and carbonates, because I feel like this is a very useful thing to understand. We'll start with the most basic experiment anyone's ever seen, and that is vinegar mixed with baking soda. And as we can see, as we mix the two, they bubble. The bubbles coming off are CO2, and probably a little bit of water vapor coming off as well, but not that much. But CO2 is the primary gas that's being exhaled here. And a good way of testing that is to actually put a flame in there, and the flame will go out. I cannot do that, seeing how windy it is, but I just wanted to show that. We've all seen this reaction before with baking soda and vinegar volcano. It's a very overdone experiment. But other carbonates will do it as well. And here I have calcium carbonate. If you have hard water, you are probably familiar with this, as it is not very soluble and it will come out everywhere. It will fill your pipes, it will form hard water stains on sinks and toilets, etc. It just crashes out of solution everywhere. It's just not soluble at all. And this is an example of choosing the proper acid, because some of these products are not very soluble. So for example, and I will say that calcium carbonate is also the component that is in Tums and in eggshells. So if you don't have access to this specifically, you do have other examples of it in case you want to do it yourself. So here we're going to mix in vinegar first. And we see that it is bubbling, though slowly. It's not very fast at what it's doing, not near as fast as the baking soda. And the reason why is that vinegar is a weak acid. It is acetic acid, but because it is a weak acid, it does not want to entirely dissociate in solution. So the reaction actually occurs rather slowly. Another acid we can try is sulfuric acid. Now, sulfuric acid forms calcium sulfate, which isn't entirely soluble. So the reaction to this is probably also going to be a little bit on the slow side. However, since this is a strong acid, it is reacting rather quickly. But if I were to dilute this acid down, it doesn't behave very well. We have tried sulfuric acid to clean the calcium carbonate stains out of toilets before, and it doesn't work very well. It has to be concentrated to do its job well. So it's kind of on the slow side. And then my favorite is hydrochloric acid. Now, I'm also about out of hydrochloric acid, also called Muriatic Acid by other brand names. When you mix this in, calcium chloride is produced, and calcium chloride is very soluble. So this bubbles rather quickly. And see, those bubbles are coming out much faster than the other two, the weak acid versus the pretty much insoluble salt. Here we have a soluble salt being produced, strong acid being used. This is just, everything is in its favor to produce calcium chloride. It just wants to react. So we can see that there's three different examples of acids being used to attack something, and the best one was actually hydrochloric acid, which is not the strongest acid I chose. Sulfuric acid is stronger. So there are aspects of this that need to be taken into consideration. Which one would you use for a job, etc. In the case of the sulfuric acid, I can use this as a fertilizer. Calcium sulfate will work fine as a fertilizer. In the case of vinegar, calcium acetate, maybe not so much, although a lot of bacteria don't have that bad of a time of chewing down acetate. But in calcium chloride, not much I can do with that. It works well as a drying agent if you need to dry things, but that is about it. And one of my favorite examples here is taking this. This is wood ash. Wood ash is a byproduct of combustion, obviously, and it consists of various carbonates and some halides. You get a little bit of calcium chloride, potassium chloride, sodium chloride, don't really care about that. But the important thing is it has a bunch of carbonates in it. Calcium carbonate, potassium carbonate, and sodium carbonate. The quantities of each depend on the type of wood you burned and the environment it came from. Okay, so let's give this a look. And this one I will do with vinegar, because I have the most of that and I want to save it. So I put it in the vinegar. We see bubbling is occurring. Once again, weak acid, and this isn't pure carbonate, so it's not going to bubble as ferociously as, let's say, baking soda would, or the hydrochloric acid would, but nonetheless it bubbles. I like to point out wood ash as a possible component to use, because in a lot of the experiments that I do, I actually use wood ash to neutralize it. Why? Because it's free, and I like free. But you might have a different reason behind what you use. If you're doing for example, a baking soda and vinegar volcano, maybe you don't want to use baking soda and vinegar. I guess then it kind of defeats the purpose. But maybe you would like to use something like wood ash, which gives it that dark color, and sulfuric acid, in which case it smells like sulfur, although do this with some ventilation, and it's also dark, which means it kind of matches that volcano look a little bit more. So there are different reasons why you might use different acids and bases. For me, I usually use this because I can make a fertilizer out of it. I can dilute it down and spread it out in my yard. Where if I did baking soda, it's really high in sodium, so that tends to kill plants. So it's completely up to you, but I did want to show a video demonstrating how acids and carbonates react. Thank you.